All right, we're back, and this is our coworker. So we felt that we had to give him a quick introduction because where would we be if we didn't give him this introduction? So this is a statement that Lee asked me to write, that he asked me to prepare for
Great.
him before this talk. So this is the direct quote from Lee. So he says, "What did you just say about me, you hecking cowboy? I'll have you know I graduated top of my class in the Hashcat University. I've been involved in numerous secret pull requests to the Hashcat code repository, and I have over 300 GPUs in my basement. I'm trained in guerrilla password cracking tactics, and I'm the top contributor to hashes.org in the entire US. You are nothing to me but just another dictionary. I will wipe you out with the precision mask attacks like the which have never been seen on this earth. Mark my hecking words. You think you can get away with these pull requests? Think again, cowboy. As we speak, I am contacting my secret network of GPUs across the USA, and your IP is being traced right now, so you better prepare for the storm. The cluster that wipes off your pathetic little thing you call your password. You're cracked, kid. I can crack your password anytime, and I can use it in over 700 ways, and that's not even including my FPGA. Not only am I extensively trained in password-free combat, but I also have access to the entire arsenal of the crypto miner underground and will use it to the full extent to wipe your miserable password off the face of the continent, you little hacker."
Please welcome the password king, Lee.
Welcome to Hashes, Smothered, Covered, and Scattered, Modern Password Cracking as a Methodology. My name is Lee Wangenheim. I'm a security consultant here at Optiv. I hack things for fun as well as for a job. If I wasn't getting paid to do this, I'd be doing it on my own anyway. I've got about 5 years of InfoSec experience, mostly focused on the offensive side of the house, and currently I'm helping to run the crackers that we've got here at Optiv. So, why does this matter? Because it only takes one password, and as we know, people tend to use weak passwords. Some examples that we've seen are on actual gigs are using default passwords for Cisco devices, Microsoft SQL Server. I've even seen iDRAC accounts using the default root and Calvin. And everybody's familiar with the fall 2019, or I guess now it would be summer 2020. This is a real issue, and we run into it more often than not. And once we've got one foothold into your network, we can use that to move laterally as much as we want. Some of the hardware that we're using. So we used to use CPUs and rainbow tables. CPUs not really worth it anymore. They've kind of been overpassed now that the modern GPU rigs are out there. We used to use a lot of rainbow tables to look up, especially in NTLM and more common hash types. However, those have been kind of supplanted by the new GPU cracking machines. The reason behind that is it's actually faster to use a GPU to crack the hashes via a brute force attack than it is to try and do a rainbow table lookup. Because again, you're burning CPU cycles doing rainbow table lookups versus GPU cycles with the new modern GPU setups. We do sometimes use cloud using the AWS boxes, the new GPU boxes. Those are pretty handy. They are expensive. However, if you do need to throw a lot of power at a hash or a series of hashes, it can be beneficial to go ahead and do that. Sometimes if we're on site and clients don't want their hashes leaving, or if we're on a Wi-Fi gig or something like that, we will use a laptop. Typically a gaming laptop will do better, but you use what you have, right? If you do happen to still be running a mining rig in 2020, for some of the GPU mining rig, GPU crypto algorithms such as like Ethereum, you can use those. And you can always make a little bit of your money back. I don't do any more mining, so I don't know exactly how useful that is in today's world. So, talking about AWS, some of the engagements that we do run here at Optiv are more of an enterprise security assessment, which is where we'll have a company provide every hash throughout their Windows domain, and then we will throw as many resources as we can over a certain amount of time, usually about 2 weeks, of just letting the crackers run, and we'll try and crack as many of their passwords as we possibly can. That kind of engagement is sort of where this methodology really was born out of, as well as some of the tools that we've built internally that I'll be talking about later have come from. So this is sort of where the cloud is as of 2017. Unfortunately, we don't have too many updated stats, but it's just about the same. So it used to be about 14 cents per gigahash hour. And now it's close to 3 cents per gigahash hour. Now we do have our internal crackers, which you can see are running at about 0.7 cents per gigahash hour. And we built those for about $25,000. So if you're working for a large consulting firm that has the capital to invest in their on-site cracking machine, you can absolutely save money by doing that. However, if you're either like a small-time consulting firm, or you're doing this as kind of like a single contractor or something like that, absolutely look into some of the AWS machines. So the P316 is currently the largest instance that you can get with GPUs. So that's going to be kind of the best bang for your buck if you're looking to throw a lot of power, as well as using a new tool that we'll touch on in a little bit called Hashtopolis, which allows you to do distributed cracking by attaching multiple versions of those multiple instances of Hashcat together. And Hashtopolis kind of acts as an orchestration engine, handling the binaries and farming jobs out across all of those different platforms, which will allow you to combine both your in-house and your cloud instances, and really start throwing massive amounts of power. You just do have to keep in mind that everything will come with a cost. Hashtopolis is free. AWS instances are definitely not. So this slide is shamelessly borrowed from the Terahash Corporation. They run the Brutalis, or they produce the Brutalis machines. So currently, you can see their largest one is running 448 NVIDIA RTX 2080s. So if you're looking at running against, running a brute force attack, you're talking doing the entire 8-character key space, instantly. So 8-character passwords are absolutely in 2020 dead. I gave a version of this talk in 2019 and said that they're dead. The same was true in 2018. It's definitely true now. The amount of power that firms are able to throw at brute forcing, especially NTLM hashes, is just absolutely incredible at this point. And so really you want to work on instructing your individuals to have strong 12-character passwords. As you can see, the exponential growth is just incredible. So you have from an 11-character password to a 12-character password. It goes from a 2-week crack time on an NTLM hash to a 3-year crack time. And this is obviously assuming that password is not going to be in any sort of a word list or any sort of a mask that we can create. So just so that we're all speaking the same language, I'll go over a few key terms, some of which you've probably heard me using previously in this talk, and I'll continue to use throughout the talk. So masks are the makeup of a word broken into its character set. This is pretty important. This is, so for instance, if you had password 1 with a capital P, and then all lowercase letters, and then 1, the mask is going to be, capital letter, 7 lowercase letters, and then 1 digit. This becomes really important when you're talking about attacking large numbers of passwords, as you can sort of guess at the makeup of people's passwords. For instance, if I tell somebody that they need to make a 12-character password that has a capital letter, lowercase letters, and digits, the vast majority of English-speaking individuals are going to create a password that starts with a capital letter, has 10 or 11 lowercase letters, and then has trailing digits. Password 1, summer 2020. We've all seen all of those on engagements. It's very, very common. Very rarely will you see them shift where the middle characters have your uppercasing or things like that. It's kind of attacking that human psychology and the human linguistics of how we form words, especially in the English speaking. I did read a very interesting article written by a linguistics professor that kind of touched on differences that you'll see in Asian languages, especially in also some of the Cyrillic languages as far as password creation and the different masks that we'll see. Unfortunately, I haven't worked too many, I haven't worked any engagements that really leaned heavily on anything other than the typical English character set. So that's where my main focus is, especially when it comes to password cracking. Hybrid attack is where you're going to be brute forcing. So again, brute forcing is just guessing every possible combination of inside the character space. So A through Z, digits 0 through 9, and then all of your special characters. So if I have 8 character passwords, I would start with 8 A's and then 7 A's and a B, and then continue to work my way through as I've tried every single character set that we can against those hashes until we get a match. So a hybrid attack is going to use that brute force attack, and then you would take a mask and either append or prepend. So if you had, say, a company name, right? If you knew that they had something like a 5-character password and you wanted to try adding like the year to the end of it, so you would do like brute force all character sets for 5 characters and then add the year on the end of it as the hybrid attack. So the year would be your either append or prepend. So a word list is much different than a password dump. So a word list, and this is a very important distinction, a word list is the candidate of words that you're going to either run by themselves or be modified with rules. So these are going to be dictionary words. This is not supposed to be a password dump. So the difference being a password dump is going to be passwords that have already been cracked, whereas a word list is going to be basic words like summer or spring, and then you can use those words and then modify them via rules in Hashcat to create different candidates for cracking. If you take a password dump that has like summer 2020 and apply rules to it in Hashcat, sometimes those rules will either append or prepend different character sets. So you might get summer 2020 using summer 2020 in a password dump as a word list. So that would be the distinction there. So this is one of my favorite quotes. If your only tool is a hammer, then every problem looks like a nail. Obviously, Mark Twain. So that's what we'll touch on here in a minute. This is the kit that we use. I'll go into what each of these tools does in the next few slides. So Hashcat, it's now the de facto standard as far as password cracking is concerned. It supports just about every hash imaginable. I believe they fixed it, but there was one time that I did have a weird zip file that I did have to use John the Ripper on but I've never really encountered anything on an engagement that Hashcat can't really do. John the Ripper was the de facto standard, 5 to 10 years ago. Again, it uses the CPU cracking. Hashcat is, using GPUs. It's very, very well maintained, constantly updated, and lots of improvements. Super easy to set up and to integrate with other tools. Also, there's so much information and documentation out there about using Hashcat, so if you ever have issues, you can always look it up and usually find the answer. Hash topless. This is what we've been using to kind of integrate our distributed cracking operations. So this is a wrapper for Hashcat. What it does is it manages agents, jobs, word lists, and Hashcat binaries. So basically, you log into a web portal via hash topless, and it goes and connects to all the different Hashcat instances that you've connected to it. You feed it a list of hashes, and you tell it to crack. And then it goes and farms all of this out to those different Hashcat instances and does all of the work for you, basically. The other great thing is if there's a new Hashcat binary that comes out, you can push an update to all of your distributed instances via hash topless. So, for instance, if you have a bunch of AWS instances spun up and you wanted to quickly spin up new ones or push like a new binary, you can do that very, very easily within hash topless. We don't use this a lot. This is really more for those big enterprise engagements, only because the cost of running a lot of distributed AWS instances does become prohibitive, especially if we're just looking for cracking a Kerberos hash or things that we can typically do on our internal cracking machines. Hash ID. So this used to be a lot more useful. It's not like the most useful anymore. This is if you're having trouble identifying what kind of a hash you've caught. So you find a list of hashes on a client gig, and you're not quite sure what you've got. You can use this. The nice thing about this is it is offline compared to some of the online systems that you can drop hashes into. So if you're trying to keep sensitive data off the internet, you can do it. You can if hash ID isn't working for you, and you've got a new kind of hash that you're not sure on. If there's open source code on GitHub, you might be able to see what kind of a hashing algorithm it's using. So, if you get it off of a new web application, you can always try and create your own hash and see if you can also self-register. So if you somehow get into like a database backend and you're able to self-register on the web application, so you could create a password of password1 and then go try and crack that password that the password and try and figure out what kind of a hash it is from there by throwing different kind of hashes at it. PWSpy is a tool that was built internally for Optiv, but it is open source. Some of the cool things that it will do is it will go out and find the most common masks for you. So if you're cracking, again, 20,000 passwords and you've cracked, say, 40% of them on your first pass through, you can have PWSpy analyze those hashes for you, and it will go ahead and tell you which masks that you can then plug into Hashcat for potential more success. So say they're having, the client has a 12-character minimum, so you find everybody is running, uppercase letter, 10 lowercase letters and then a digit or things like that. It will also identify weak passwords, so You can kind of tweak that with some of the settings in there by saying, only words or only words in a digit or things like that. It will break out the different password lengths that you have. It will also pull out different base words. So if you're doing an engagement and you find that people are using seasons or the client name over and over again to create passwords, you can absolutely use this and show that as evidence to your client to say, maybe you should put a blacklist policy in for different password terms and things like that. The other thing that it will do is it will analyze and find reused hashes. So if you find multiple people are using the same password, this will identify that, so you could then point that out to the client. It's not usually a big deal if it's summer 2020. I mean, it's a big deal, but it's not, a deal with people sharing passwords. But if it's more of a complex password that you find multiple times, that could indicate that people are either sharing their passwords or somebody's reusing passwords for, say, their local account and then their administrator account, or even DA creds or somewhere in a SQL server. Feel free to go download PW Spy. It's open source, and I've had a lot of people reach out and suggest edits or find bugs. So please, if there's anything, please feel free to either put in a pull request or whatever on GitHub, or reach out to me via Twitter or through GitHub. So some of the techniques that we use, so this is how we kind of hone our skills. So how do you begin? What's the best way to crack a hash? Well, so this is a loaded question to me. I get this a lot from our internal team. It kind of drives me a little bit crazy because it's kind of like asking what's the best way to use Nmap. There's no one right answer. So basically it's kind of an experience, and just depending on the goals of your engagement, what are you looking to do? So are you after one hash? Are you after multiple hashes? The algorithm that you're going after is very, very important. So, an NTLM hash, you're going to be able to throw a lot more power at than WPA2, only because it's a much faster algorithm. So you're going to be able to throw more rules and more word sets. One thing we've done in the past with client engagements is, if we're on a wireless gig and, say we only have a day or two on site, and we know that they're using a pre-shared key, what we'll do is we will have the client provide us that key and create that hash in either an NTLM or an MD5, and then run it against our rule sets and our word list to then demonstrate the impact to that client that says, hey, we didn't have enough time to crack the WPA2 while we were on site. However, we would have cracked it. So, if you have somebody sitting in your parking lot and they capture, they could potentially come back and get into your network that way. And this is, how we did it. So that's one way to kind of work with your clients. So where do you get hashes? Always looking for hash dumps. If you can get onto a Linux box and you have root access and you can dump etc shadow, comp files are always great. Backend databases that you can get into. Mimikatz if you encounter like an older Windows system that's not fully patched. Web applications a lot of times will expose hashes, either via misconfigurations or just having their database exposed. We run a lot of Responder or Man in the Middle 6 on internal gigs. I'll do a demo of that in a little bit. DC Sync and NTDS. These are some of the common ways to find hashes. There's thousands of ways to find hashes. If you're on a wireless gig and you capture a pre-shared key handshake, you can open up Wireshark and get the PSK hash out of there. There are just many, many different ways to get hashes. These are some good ways to start if you're kind of looking to get into it. I would highly recommend kind of building a local lab, setting up, responder on your local lab, or setting up a database, making some hashes, and then just going ahead and trying to crack them. You can also just create a bunch of NTLM hashes or MD5 hashes via some scripts. So make a bunch of passwords that and test it out in Hashcat. So that's a good way to get started. So developing a methodology. So this is really where our password audit kind of came out of. So we wanted to create a repeatable process for other people on our team to be able to follow and make it as easy as possible for a new consultant to just kind of get spun up and start working. These are going to be much more analysis based than hands on the keyboard. This is going to be a lot of letting the cracker run, using your various rules and masks and all of the stuff that we've discussed previously, looking at the results and kind of figuring out where you want to go from there, looking at what their hashes are doing, looking at what the passwords they're using are they a secure company? Are you seeing a lot of crazy hashes that you're not able to crack, or are you seeing a lot of like really simple passwords? The other thing we're going to look for is common words, easy wins. Again, I keep coming back to summer 2020, password 1, company name and the date that it was founded is a really popular one. Street names. If you're in an area, if you're doing a client and there's a local sports team, I'm from Ohio, so in my area, you find a lot of Ohio State or Buckeye related passwords. You could extrapolate that across the country. New England, you could do Patriots or whatever. We'll find a lot of times clients will claim that they do their own password audits, but they're not really doing it effectively. They might run Hashcat with like a base word list or like a RockU or something like that, and say that they covered it. You really, for these enterprise engagements, you need heavy hitting cracking rigs, either built in house or setting up the cloud. And I would say even just one Amazon P316 is not going to really pass muster for this. You're going to want to throw a good amount of resources at these, especially if you're talking 20,000 or more passwords that you're trying to recover. So what do? Again, we go for quick wins. So we run, internally we have some proprietary word lists that we use. It's kind of been tweaked over the years. It has a lot of data from all the different breaches where we've extrapolated common base words, things like that. And we'll run those without rules. And then we will slowly start adding things that increase the time of cracking, but also increase your possibility of cracking more passwords. So we will continue to run newer and newer attacks against the same list of hashes. And as you'll see in a second, it's kind of the law of diminishing returns. But as we move through the process, we tend to be pretty successful. We do in-house, we have the capability to do a 1 to 8 character brute force. That takes about 24 hours on our in-house crackers. So we can brute force the entire NTLM key space within a day. So that's usually about the first day of a password engagement. And then we will run our word lists and then our rules against things after. We we'll then use either PW Spy to create different masks, or just use common masks, things like that. And just kind of moving on and doing more and more advanced attacks as we get closer to the end of the engagement. So this is sort of what, this is actually real data, and this is what our password recovery over time looked like on a recent password assessment. So as you can see, within the first few hours, we cracked the majority of the passwords we were going to crack, and as we moved through, you can see the longer password recovery attempts did yield less results, but out of I believe this was about 18,000 passwords or hashes that we were trying to crack, and we cracked almost 14,000 of them, which is pretty good. That was enough to show an impact to the client, and this is over about 2 weeks of letting the crackers run and then doing a lot of that analysis on the back end and tweaking the rules to match what we were seeing. So how to help your future self. This is really important. So you want to have your pot files. We'll typically separate out pot files based on clients, but we also keep a master pot file. That's a historical record of your cracked hashes. It's useful to see if you've already cracked that hash on another engagement. So if you're seeing summer 2020, you're not going to burn cycles trying to crack it again. We'll just try that hash. This obviously doesn't work against salted hashes, but it will work against NTLM or any of the MD5 or things like that. Do be really careful about bloat. It can slow down the process, because it's going to check it against the existing pot file. So, for instance, we did have a pretty overzealous analyst on the team who decided to add the entirety of the LinkedIn dump into our pot file. And at the time of the dump, LinkedIn did not have any password restrictions, so you had a lot of 4-character passwords or just plain text passwords, which is pretty useless against enterprise networks that are running either an 8-character with complexity or 12-character with complexity. So you do want to be careful of that because you're going to be running each hash against that pot file, and again, you're going to be burning CPU cycles on that. Common masks. So we keep a list of in-house tools that includes the masks that we can copy in to our hashcat commands, as well as creating new masks as we see fit on the engagements. But the common ones would be uppercase letters at the beginning, and then trailing lowercase letters with digits at the end. So now we're going to move into a demo. I'm going to show you sort of what a typical engagement might look like, on a client network. Okay, so for this demo, I have a responder lab built using VirtualBox on my Windows machine. So what I've done is I have set up a domain controller, a firewall appliance, a Kali machine, and a Windows 10 machine. So you can see all of the machines are up and running. What you see here is IPFire is running to route everything together. Windows Server 2012 is currently running to act as the domain controller and the DNS. Obviously Kali, which is going to be our attacking machine, and then the Win eval is going to be your Windows 10 simulating a client computer. Okay, so closing that out, we just want to verify it once again that we are on the same network, so we can see both of these hosts are actually networked together on the same subnet. So we'll go ahead and start up Responder here. So when you start up Responder, you have to feed it the interface that you're using. So what Responder is doing is poisoning the LLMNR and NBTNS requests that Windows machines will set out. This happens if Windows can't resolve a hostname using DNS. It will send broadcast traffic out asking for that information. So responder kind of steps into the middle between a domain controller and the Windows machine, and will respond with the information that they're requesting, but it will then ask that Windows machine to send its authentication to it, which the Windows machine will provide, and then responder will capture those hashes. You can usually accomplish this by trying to access something that doesn't exist, such as like file share does not exist or something like that inside your network libraries. And that should be sufficient to generate the LLM in our broadcast traffic. And we'll see an example of that here. So I open up the folders and I go to server does not exist. And you can see the poison answers are being sent and we're capturing NTLM v2 hashes. Now this is important. As we start capturing the NTLM v2 hashes, you'll see there are multiple hashes being captured. These are actually the same hash, just due to the nature of NTLM v2. They are salted, so you will receive multiple hashes. When you are going to crack these hashes, what you'll want to do is take one hash per username. That way you're not spending excess time trying to crack the same hash for a user that you've already cracked, or for a user that you're not going to be able to crack. So once we've got that hash, we can just copy it over into a text file, which I do here. So you can see I drop it into hash.txt. And you could do this for as many of the usernames and passwords that you capture. Hopefully you get something juicy. Like sometimes you'll be able to get like DA creds or things like that. Okay, so now that we've got hash.txt created, we're going to go ahead and start up hashcat. So NTLM v2 hashes are mode 5600. So to accomplish that in hashcat, you feed it the TAC-M flag and then 5600. Then you feed it the file name, and then in this particular example, we're using a little bit of a contrived example just for brevity. So we're going to use fasttrack.txt because I happen to know that this particular password for this user, again, because I've created the lab, will be in that. Now, if this is a live gig, that's where you're going to feed some of the more advanced masks or rules, or definitely stronger word lists, things like that. But you can always start with the quick and easy ones, and maybe you'll get lucky. And if you do, that's awesome. You haven't spent a lot of time. However, if you do need to use those heavier lists, please feel free to, and definitely use the masks and such that you've got working. So we start up hashcat here, again using the mode 5600, and then we feed it the hash.txt that we created, and then we go ahead and feed it the particular word list, which in this case again is stored as user share word list, and then we're just using the fasttrack.txt. Once hashcat starts, again this particular Kali instance isn't hooked up to my GPU box, so you'll get some warnings for OpenCL and things like that, but you'll see the warnings come through, and then just because I know that this works really quickly, you'll see that this cracks, and you can see password 1 is our cracked password. Now, if we were cracking multiple passwords, or take longer, you would see those in your pot file. You can also create a new pot file by doing pot file path equals, and then name your pot file whatever you want, and that will create a pot file specifically for that particular session with Hashcat. That's useful if you're running an engagement for a particular client and you wanted to separate out the hashes that you've cracked from them versus the other engagements that you've worked. So you can see here, as the hash is cracked, it will append the password to the end of the hash file, which will be the exact same way it's presented in the pot file as well. So now that we've got our password, we can then go ahead and use those credentials to go and log in via Windows, doing any particular thing that we might want to do. Okay, so with a little bit of time that we have left, I'd like to do a quick demo of PW Spy, as it's kind of a new tool that I've developed, and it was originally released during 614Con 2019. However, it's gone through some pretty major changes, and I'm happy to announce that the newest version is now live on GitHub for you guys to go ahead and go grab if you so choose. So, again, this was an internal tool developed mostly to help us deal with the massive amount of information coming from the enterprise password audits. So the intention was that you would take a pop file that you've created specifically for your particular client or engagement, and then you would feed that as well as the initial hash list that you fed into Hashcat, and it would do the analysis for you. That's pretty much been accomplished. There's still a few more bugs and things that I'd like to tweak. However, let's get into it. For this particular demo, I went ahead and grabbed some of the passwords that we've seen in some of the public dumps that are out there. And I went ahead and created some NTLM hashes using those passwords and cracked them using the Optiv cracker to generate the pop file for this demo. So that's what you're going to see here. So I'll go ahead and open up demo.pot. As you can see, these are just some common passwords, and they've already been cracked. So it's time to do the post-session analysis on that. So we're going to go ahead and feed this file into PW Spy. Now, PW Spy, if you open up the help options, you'll see that you can feed it both a pop file and a hash list. The hash list is actually optional. You don't have to add that, as well as inside the Python script, you can turn on and off individual modules simply by commenting them out in the calls. Those are down at the bottom of the script, and I'll show you that towards the end of this demo. So in this particular case, because we're using like a publicly available passwords, and we haven't cracked a bunch from a particular company, so there's not going to be any reuse. There's really no sense in doing the hash list as well, so we're not going to feed that in, as well as some of the modules may not work because there's just not enough data, such as the mask builder, and definitely the password reuse won't work because you need to feed that the hash list. So we'll go ahead and run PW Spy, and we'll take a look at the output. So you can see here the output is a pretty standard script output. complete with the required ASCII text for any cool hacker tool, of course. So this shows you some of the various modules that have worked. So as we scroll back, you can see that we have the common base words and the number of times that we've seen those, as well as there would be a password reuse, and the masks would go there as well, which would help you if you were going to do further attacks against this client. The other thing that it will do is it will tell you weak passwords. So passwords, in this case, I have it to set to just passwords that are just plain text. So you can see all of these passwords were cracked and consist of only letters and no numbers or special characters of any sort. You can always make this more restrictive or less restrictive by editing the Python script. One of the goals for the future is to add options to define what a weak password would be. And then the last thing that it will do is check the lengths of all the passwords that you have cracked. And as you can see, it splits those out and gives you the number of occurrences. So there were a lot of 9-character passwords, some 10-character passwords. This really becomes helpful if you are doing, again, an engagement, and let's say the client says that they've got a 12-character password policy, and you can go ahead and check against that and make sure that you didn't capture any passwords that might not fit that policy, as well as if you're going to build your custom masks that might not be output by this tool, you would be able to use the password length to help you generate those masks as well. So the last thing I wanted to touch on with PWSpy is just kind of taking a quick look at the source code and showing where you would turn on and off those modules. So if we cat the file here, you can see that all of the function calls are down here at the bottom, which I'm highlighting here. And from there, what you can do is go ahead and comment out any of those different modules, and it will not run those. So if you didn't particularly want to run the mask builder or check for weak passwords or password length for whatever reason, you could go ahead and comment that out. Again, this is an open source tool. Please feel free to fork and edit it as you see fit. And I hope that this proves helpful to somebody or anybody if you are doing especially large password assessments. I'd like to thank you for taking the time to listen to today's talk. There's been a lot of great talks here at the Red Team Village, and looks like there's a few more after me. This has been a great DEF CON, despite it being remote. At this time, I would like to just once again reiterate that password cracking methodology is more of a comprehensive approach than a one-size-fits-all. There are many different ways and approaches to cracking passwords, and what works for one person may not work for everybody. So keep that in mind, as well as always remember that password cracking is, again, not one-size-fits-all. You're not going to be able to do this by just scripting everything. You definitely need to do that deep dive analysis, really think about what you're going after, and use that to guide the way that you go after your passwords in the future. Hopefully you have taken something away from this talk, and I will be in the Red Team Village Discord for any questions. I'm HX50 in there, as well as on Twitter. You can find me at HX_50. And once again, I would highly encourage you to go ahead and try some of these techniques out on your own. Go ahead and create hashes, set up a lab, and go ahead and crack your own stuff. I will release the instructions on how to set up my lab, as well as possibly setting up just OVA files that you can download, as well as you can go on GitHub and feel free to grab PWSpy if you so choose. You can find that at github.com/lwangenheim /PWSpy. And obviously that's quite the mouthful to try and spell. So if you do want to try and find it and Google doesn't help, feel free to reach out to me. I'm more than happy to either just provide you the link or I can just send you the files directly.